Okay, today we're going to talk about carbohydrates and start an entire section learning about carbohydrates and different things that affect the body. Carbohydrates are absolutely an important building block of plants and are used for energy in animals in large part. So plants use the energy from sunlight to make things like glucose through photosynthesis. And they make carbohydrates that have a general formula of CH2ON in any format you wish. And then we, as humans, derive energy from carbohydrates through respiration. Carbohydrates are kind of like the body's polymers, if you want to think of it that way. And therefore, that's sort of why we sort of learned about that a little bit, but also because they're so important. Monosaccharides are sort of the building blocks, right? So if you have one thing, that would be a monosaccharide, and this is an example, a poor example, but this is trying to get you through things for a simple version of them. When you combine two of these, that would make a disaccharide in this case. If you have lots of them, it would be a polysaccharide. So polysaccharides mean many saccharides, disaccharides means two, and mono simply means one. And what can sort of go through the linking process is you end up losing water a lot of times when you link things together, or if you break them apart enzymatically, they usually add water there. That's a comma, not a 2, excuse me. That's not H2O2 by any means. So water. Now, that's again just a general example as to how things link. But notice that here we sort of are losing a water, 1, 2 H's and an O, and that's how we end up with that oxygen. And when we add those back, that's how you break them apart. Okay. Now, we can term these, now that you're familiar with the Fisher projections, aldehydes become aldoses, and ketones become ketoses, or ketose. Each of these have 3 to 7 carbons and 1 or more OH groups. An aldehyde has a C double bond O and an H here, so that would be an aldose. See how this one starts with the CH2OH, and then in the middle of that ring, or that line, has a C double O bond. Well, notice that's not a hash, that's a C double O bond. Therefore, this carbon is connected to more than one carbon. It's a ketone that makes this molecule a ketose. Okay. Going back to Fisher projections, let's review how to do these. You put a line straight up and down, and CO as close to the top as possible. The non-chiral carbons are simply abbreviated, something like CH2OH, like you see down here. The chiral carbon furthest from the C double O bond is how you determine if it's D or L, and each intersection is also a carbon, so they're specifically chiral carbons. So that means you've got 1, 2, 3, 4, 5, 6 carbons there. Remember, the OH that's furthest from the carbonyl is how it gets its L versus D. So glucose tells you the patterning of back and forth with this OH. The fact that this bottom one is on the left defines it as L-glucose. If you look at its enantiomer, or its mirror image over here, see how every single thing changed, right? Well, now this OH is the furthest from the COH. This means that it's a D-glucose. Another example, here's fructose. Notice that we've got a ketone now. So this is a ketose and not, this was an aldose. This ketose, the furthest OH from the C double O bond is on the left, so it's an L-fructose. The mirror image of that changes everything. This D comes from the fact that that is on the right. Okay, so here's your list of VIMs, or very important monosaccharides. These are the ones that you need to know. first we comes with fructose. You ever heard of high fructose corn syrup? Guess what that's because? Fructose is twice as sweet as other types of monosaccharide, or different types of sugars, I should say. You need to know what this structure looks like. So, fructose is, in any way you make up a story to remember how this goes, okay? Maybe we can make one up together. Here's glucose. So notice we talked about that up above as well, both of these up above. This is in so many things, it's not even funny. It's in everything from sucrose, table sugar, to cellulose. And how we define blood sugar is because of the glucose level in your sugar. So that tells you how much that is relevant to your body. And here we have galactose. This is from lactose in milk. It's also very important for brain and nerve function. So this is the other one that you probably need to know. Thank you very much.